Hi friends, I am Sunil working as BSNL JE. Welcome to BSNL JE 2016 exam preparation. In this video, I am going to discuss electrical specialization topics. In this video, DC machines. DC machines are DC generators and DC motors. First of all, DC generator. First of all, what is a generator? It generates electrical energy. It generates electrical energy. That means an electric generator is a machine which converts mechanical energy into electrical energy. It is a generator. Generator converts mechanical energy into electrical energy. It is also one of the important bit. Okay. In case of motor converts electrical signal into electrical energy into mechanical energy. That is a motor. Okay. Coming to the principal operation of generator. What is the principal operation of generator? Is nothing but Faraday's laws of electromagnetic induction. Principle of generator is nothing but Faraday's laws of electromagnetic induction. That is, already we know what is the Faraday's laws of electromagnetic induction. Whenever a conductor cuts the magnetic flux, an EMF will be induced. Whenever a conductor cuts the magnetic flux, an EMF will be induced. That is, if it is a north pole, it is a south pole. The flux flows from north to south. Likewise, we know this. Whenever a conductor, take one conductor, whenever a conductor cuts this magnetic flux, an EMF will be induced in it. That means an EMF will be induced in conductor. This is the Faraday's law. According to this law, an EMF will be induced. That means if it is a conductor, here one pole north pole, here one pole south pole, then the flux flows from north pole to south pole. Whenever a conductor placed in this magnetic field, and when it rotates, the flux flowing likewise, and the conductor rotates this wise, then the flowing flux will be cut by the conductor. Whenever the flux cut by conductor, an EMF will be induced in this conductor. When these conductors are enclosed, that means it is these conductors closed to the any load, then an current will be flows through the load. And this direction of induced EMF in generator is determined by Fleming's right hand rule. I already explained in basic electricity videos what is the Fleming's right hand rule. Okay, in the direction, very important bit, it is the direction of induced EMF in generator is determined by Fleming's right hand rule. Okay. Once again coming to the principle, whenever flux flowing like this, and whenever the conductor cuts this magnetic flux, an EMF will be induced. In case of DC generator, field poles nothing but which are giving the magnetic flux. Field poles are stationary, and this conductor is moving, and conductors are moving by using any external source. The conductors are moving, then the conductors cuts the magnetic flux, and EMF will be induced. This is the principle of generators. Okay, and actually the nature of EMF induced in the conductors, is alternating only. That means AC only. But the generator is DC generator. So for that means the generated current is alternating but the generator is DC generator. That means this generated AC output, the generated AC output is connected to a device. Is called that device is called commutator. That commutator converts the AC to DC. Actually, in conductors, AC is generated. This AC is connected to commutator. Then commutator will convert AC to DC. Then output is DC. Okay. Here the nature of EMF induced in conductors is alternating nature. By using commutator, we can convert AC to DC. That means DC generator equal to AC generator plus commutator. Connected, and the induced EMF the induced EMF E equal to pi Pn by 60 into Z by A. The formula for induced EMF E equal to pi Pn by 60 into Z by A. Here pi means flux per pole. P is number of poles, and N is speed in RPM. RPM means rotations per minute. N means speed in units of the speed is in RPM. That means rotations per minute. Into Z means total number of conductors. A means parallel paths. This is the equation of EMF. Okay. Next, coming to the parts of DC machine, that is construction details of DC machine. Coming to the constructional or parts of DC machine, this is a diagram of simple DC machine. Okay. In this, the outermost part is called yoke or magnetic frame. The outermost part is called as yoke. First one, magnetic frame or yoke. This yoke is a outermost part. It is made up of cast iron. And the purpose of this yoke is it provides mechanical support for the poles and it is used as a protecting cover. And it carries the magnetic flux. That means the magnetic flux produced from North Pole to South Pole, and the return path is provided through this yoke. Okay. Coming to the once again yoke, it is the outermost part. It gives mechanical support, and it is used as a protecting cover, and it carries magnetic flux. And coming to the pole core and pole shows, this is pole core. It is total is North Pole. It is a pole core, and this part is called as pole show. This is a pole core, and the windings. These are the windings. That is means by field winding or pole windings. Coming to the pole core are mainly salient pole type and made up of cast iron. Poles are salient pole type and made up of cast iron. Actually, poles are two types: salient pole type, cylindrical pole types. Salient pole types is nothing but the poles look like this wise. These are called salient poles, and cylindrical poles are look like this. That means the salient poles are non-uniform air gap. This provides uniform air gap. And pole cores are mainly salient pole types in case of DC generators and made up of cast iron. And pole show, this is the pole show. It supports the existing coil. And reduce the reluctance of magnetic path. What is meant by reluctance? I already explained in basic engineering. Reluctance means which opposes the flow of magnetic flux. So it reduces, pole show reduces the reluctance. Okay, that means pole, next one, pole coils consist of copper wire. This pole coils which are rotated, this is a pole core, these are coils. These pole coils consist of copper wire, and concentric winding is used for poles of DC machine. Concentric field winding is used as for poles of DC machine. Actually, concentric field winding and distributed field winding are examples of field windings. In this DC machines, concentric field windings are used. Next, armature core. The rotating part is called as, this is the armature. These are armature. It is a armature core, and windings are armature windings. These are armature windings. Armature core, this is the armature core. Armature core, it is made up of silicon steel. And it is laminated to reduce the eddy current losses. What is meant by lamination? Lamination means converting a single core into plates. It is a single core. This single core is converted to plates of core. That means cutted. This core cutted as a plates and then connected. That means it is like likewise plates. By laminating, the total area of each plate is reduced. Actually, the area of single core is very high. When we convert or when we laminate this core, then it is converted as some plates. The plate area will be reduced. That means area will be reduced. As eddy current losses. Eddy current losses means circulating current losses. When the AC is subjected to a single core, the currents which are circulated within the core, the currents which are circulated within the core is called eddy currents. Due to this eddy currents, some loss may occur. These losses are called eddy current losses. To reduce these eddy current losses, we have to provide laminations to the armature core. No need of this much of explanation, I think. Actually, you have to remember armature core is made up of silicon steel, and this armature core is laminated to reduce the eddy current losses. Okay. Next, armature windings. These are armature windings. These are mainly two types: lap winding and wave winding. Coming to the lap winding, the parallel paths of lap winding is equal to poles, number of poles. Here for wave winding, parallel paths is only 2. If for example number of poles are 4, it has 4 parallel paths. For the same 4 poles, it has only 2 parallel paths. It is independent of poles. The parallel paths are fixed, that is only 2. And this lap winding is used for high current generators. This is used for low current generators. Why? Because it has the number of parallel paths are very high. For in case of number of poles are 8, it has 8 parallel paths. That means the current in each, total current is current in each parallel path. That means I1, I2, I3, I4. I1 plus I2 plus I3 plus I4. So the current capacity is very high. So that's why it is used for high current generators. That means low voltage and high current generators. And it is only 2 parallel paths. That means it is used for low current and high voltage generators. Very important bit is lap winding is suitable for dash, low voltage and high current generators. Wave winding is suitable for high voltage and low current generators. Very, very important bits. Each and every line are very, very important for bits. Okay, I am next one. Equalizer rings are needed for lap winding. Equalizer rings are needed, and for wave winding there is no need of equalizer rings. What are the equalizer rings? We know that the number of parallel paths are very equal to the poles, and they are very high than the wave winding. That means the current distribution is unequal. The current distribution is unequal in each path. So to get the equal distribution of current, these equalizer rings are needed. But in case of wave winding, there is only two paths. That means current is divided to each path. That means total current I equal to I1 plus I2. So current is divided in each path. So there is no need of equalizer rings, because there is no unequal currents distribution. Okay, and no need of dummy coils in lap winding. Here dummy coils are required. That means in case of wave winding, why dummy coils are required? The purpose of this dummy coil is to give mechanical support. Okay, next part, commutator. Very, very important one is commutator. As I already told about this commutator. Commutator is act as a mechanical rectifier in AC generators. It act as a mechanical rectifier in DC generator. That means it converts AC to DC. Actually, the current induced in DC generators is AC, but by using this commutator we can convert AC to DC. In case of motors, the commutator act as a inverter. That means it converts DC to AC. Next main part is brushes. Brushes are made up of carbon or graphite. These are called as brushes. These brushes are made up of carbon or graphite. The purpose of this brushes is to collect the current from the commutator. Okay, next, types of generators. Coming to the types of generators, there are mainly two types: separately excited and self-excited. That means in case of separately excited, the field magnets, that is our N pole and S pole. These N pole and S pole are electromagnets. That means they need excitation. This excitation is provided by external source. This type of generators called as separately excited. Self-excited generators means the field magnets are energized by the current produced within the generator. Actually, the generator generates the electrical energy. By using that electrical energy, the field magnets are energized. And these self-excited are divided into three types: shunt wound generator, series wound generator, compound wound generator. That means in case of shunt wound generators, the field windings are connected parallel to the armature winding. In case of series wound generator, field windings are connected series with the armature windings. Compound wound generator, it is a combination of series and parallel. It is a combination of both series and parallel. Next, losses in DC generators. First one, copper losses. Copper losses are nothing but I square R losses. There is copper have some resistance, and whenever current flows through these coils, and I square R losses will develop. That means these losses called I square R losses. These losses are nearly 30 to 40%. Nearly 30 to 40%. Next, iron losses. Iron losses are divided into two types. First one is hysteresis losses and eddy current losses. This hysteresis losses due to magnetic reversals. Due to magnetic reversals. That means magnetization and demagnetization. Due to this process of magnetization and demagnetization, some losses will occur. These losses are called hysteresis losses. Eddy current losses, as I already told about this eddy current losses. These both losses are 20 to 30%. Next, mechanical losses, that is frictional and windage losses. Whenever the motor rotates, some frictional losses occurs. These are 10 to 20%. These are 10 to 20%. And some important bits regarding to this DC generators are equalizer rings. I already told about equalizer rings. They are used in lap winding for getting equal distribution. And dummy coils. These are used in wave winding to provide mechanical balance. And next important topic, armature reaction. Actually, in DC generators, their main two parts are field windings and armature windings. Field winding, NS, and armature windings. Here, what is the armature reaction means? The effect of this armature flux on main field flux. Main field means poles. And the effect of this armature flux on main field flux is called as armature reaction. Actually, take these are poles. The main field flux, this is the main field flux. We know that armatures, here also poles, here also some magnetic flux. The effect of this armature flux on these main field flux is called as armature reaction. It has two effects. That is, first one is it demagnetizes or weakens the main flux. It weakens the main field flux. If main field flux is weakens, there is we know that E equal to minus d pi by dt. And whenever the flux changes will reduce, then an EMF will be decreases. And it cross magnetizes and distorts it. That means it cross magnetized and distorts the main field flux. And it can be decreased by, that means armature reaction can be decreased by, first one, by using interpoles. Some extra poles are connected to reduce the armature reaction. By providing compensating winding. The compensating winding is connected to the armature for reducing the armature reaction. And coming to the applications of this DC generators are separately excited DC generators. These are used in Ward-Leonard systems. Separately excited DC generators are used in Ward-Leonard systems for speed control. Next one, shunt generators. These are the characteristic of these shunt generators are constant. They will give constant voltage. So due to this characteristics, they are used for charge batteries. That means charging to the batteries. Next one, series generators. Due to this rising characteristics, they are used as boosters. Very important. Series generators are used as boosters. They are mainly used in railway applications. And compound generators, they are a combination of both series and shunt. These are used for whenever we need constant output voltage, for lamp loads and heavy power services.
Okay. Okay, thank you friends. In next video I will explain DC motors. Okay. Okay, thank you, all the best.